Natural logarithmic differentiation. We know for integrating your general power rule. We have that. Sometimes that works well. Sometimes it doesn't work well. Sometimes using the idea of logarithms is helpful. So let's first of all review natural logarithms. A natural logarithm is log base e. Well, here's the graph of our natural log on the right. Remember, anything after your log always has to be positive, hence the domain is always greater than 0, and your graph is only to the right of the y-axis. Your graph goes down forever, eventually goes up forever, so your range is all real numbers. It's continuous. You'll notice as you look at your graph, it always increases as you go to the right. It's a 1-to-1, meaning it passes the vertical and horizontal line test. You'll notice the concavity structure of this is always concave down. Also, reviewing properties of logarithms. Natural log of 1 is 0, because log base e of 1 means e to what power is 1, and that is 0. Remember, if you have two things multiplied together after a log, you could break it apart, go log of the first one plus log of the second one. Same thing with division, or similar with division. You take log of the first one minus log of the second one. Then if you have an exponent after your log, remember you can take that exponent, put it down in front. Those are the main properties of logarithms to just refresh your memory on. So let's use those properties of logarithms to expand this one. Now we have the log of two things divided. So we'll take the log of the top minus the log of the bottom. Well, we're going to keep the first one the same for now. Now we really have the log of two things multiplied together here. So we should be able to break that apart and add. Well, to do that, you might be wondering, why do we have a subtraction? Well, it's really this whole thing in parentheses with a plus sign here. But when you distribute through your negative, it then becomes a minus sign. Well, the one thing we want to do last is to get our exponents down in front. So this exponent of 2 will go down in front. Here, there's no exponent. We leave it alone. Our exponent of 1/3, because our cube root is a 1/3 power, our 1/3 goes down in front. Here's the definition of e. It's this limit. It's approximated by the number over here on the right. It can also be defined as natural log of e is 1, which is your definite integral from 1 to e of 1 over t dt. I prefer the first one for your definition, but it can be defined as the second one. Now, when you're dealing with the derivative of a natural log, the derivative of a natural log is really just 1 over what was after your log. However, if it's more than just an x after your log, it's like an x squared or something like that, another function. When you take your derivative of that, it's really 1 over what was after the log times the derivative of the inside, what was after your log. So it's basically the chain rule. So the derivative of a natural log is just 1 over what's after your log times the derivative of the inside. So let's go ahead and take the derivative of this. We do have a quotient, so we're going to use our quotient rule. We'll take the derivative of the top. Derivative of natural log is 1 over x times the bottom minus the top times the derivative of the bottom, which is just 1, over the bottom squared. Well, then we're going to do a little bit of simplification. Our x times 1 over x is 1. Then we just get a natural log of x over your x squared. There's nothing more we can do there. Taking a look at the one here on the right, we need to take our derivative, but it's going to be easier to think of our square root as a 1/2 power. Then we'll use our power rule. We'll put our 1/2 down in front, put the inside down, decrease your exponent by 1. Then we're going to multiply it by the derivative of the inside. Well, the derivative of 1 is 0. Derivative of your natural log is 1 over x. So all we're going to do is simplify this. This is a negative exponent, moves down to the bottom. 1/2 causes a 2 to be in the bottom. Our 1 over x causes this x to be in the bottom. Remember, this is a negative 1/2 power, so it moves it down to the bottom, becomes a positive 1/2 power, which is really your square root. Well, we want to go ahead and take the derivative of this. Well, for the most part, it's going to be easier to think about this right side using our properties of logarithms. So we have a number after our log, so we're going to put it down in front. If you use your properties of logarithms to expand your initial problem out, it makes it a lot easier to take your derivative. Because otherwise you'd have to go 1 over this and then multiply it by the derivative of this whole big, messy, ugly root, which is repeated chain rules. So we're going to continue to take what we have on the right. We have the log of two things being subtracted or divided, so we're going to go ahead and subtract. Now we're going to go ahead and take our derivative. 1/2 derivative of this means 1 over that times the derivative of the inside minus 1 over this times the derivative of the inside. Distribute through our 1/2. Our 1/2 undoes our 2 here. Our 1/2 undoes our 4 here, giving us a 2, so we have a 2 on top. Now we're going to just go ahead and find our common denominator, which is this one times this one. So our first fraction has to be multiplied top and bottom by our 4x plus 5. Our second one has to be multiplied top and bottom by our 2x plus 3. Write it as one fraction. Simplify the top, you get -1. If you wanted, you could multiply the bottom out, so this is our derivative. It's much easier to take our derivative of this problem using properties of logarithms to expand it first, then take your derivative.